Hello everyone, I am going to explain the basic architecture of vSAN, VMware vSAN. Okay, let's first I would like to tell you when it was introduced. The vSAN is introduced, they introduced in 2013 as you see in the slide. So previously it was virtual SAN, now it is called vSAN. Today it's officially known as a vSAN, but it is what most people always call vSAN. Okay, so what is vSAN? Why we need vSAN? So first, let me tell you about what is vSAN. So VMware vSAN is a software-defined enterprise storage solution that supports hybrid converged infrastructure system. The vSAN is fully integrated with VMware vSphere as a distributed layer of software within the ESXi hypervisor. vSAN is aggregated local or direct attached storage device to create a single storage pool shared across all hosts in the SAN cluster. The hybrid cloud vSAN cluster used flash devices for a cache tier and magnetic device for a capacity tier. An all flash vSAN cluster use a flash device for both the cache tier and the capacity tier. The architecture create a flash optimized resilient shared data store designed for the software defined data center as SDDC. So and vSAN eliminate the need for external shared storage. That is a very important thing, key aspect why we are using the shared storage. So it is eliminating the need of external shared storage and simplify storage configuration through the storage policy based management SPBM. It says in a short span we can say SPBM, storage policy based management. Using virtual machine storage policy you can define storage requirement and capacities, capabilities. So that is very important thing. And another thing is I would like to explain overall the architecture and how it works, other stuffs. So main thing is where we required the high availability should need, and DRS must be enabled in the vSAN architecture. So and as of all of you know that VM kernel port should be created in each ESXi host. That is very important thing. So every every ESXi host is connected to the physical switch. So each ESXi host have its own redundancy. So it might be one port is connected to one switch, another port will connect it to another switch. So it have its own redundancy in the architecture itself. So it totally the data will be transferred through the VM kernel port only. VM kernel port should be enabled for specific vSAN alone. So while we are creating the VM kernel port, we should enable the vSAN in the kernel port. That's very important thing, and all of us should know that. So another thing is two type of disk we have in this architecture. One is flash drive, which is called SSD, and another one is magnetic disk, which is capacity disk. So always the performance, if you compare the performance between the magnetic disk and the flash drive, it's the flash drive is more faster than the magnetic disk. It's a old thing. The magnetic disk is the old one. So newly we are using, the fast performance wise it is very much fast, and the cost wise it is very high. The SSD is very high, and the magnetic disk is it's the cost wise it is low. So that is a one main thing. So each ESXi host we have our own capacity disk and SSD disk. So what will happen in every ESXi host, we have a capacity and SSD. So every time the data will be written across the ESXi host. For identity perspective, it will be written across ESXi host. For example, we have host A and host B. If we have a VM1, so VM1, if something data will be written, automatically it will spread across the data ESXi host 1 and ESXi host 2. So the data will be split and written to the both ESXi host for identity perspective. If for example if the host A goes down, automatically we can recover the data from the host B. So the very important thing. And another thing is why how it is fast, how it is different than other architecture. So simply when the data will be when the data while reading, automatically, so the frequently reading data will be captured in the SSD disk. So whenever user reading anything, any data inside the VM, automatically first it will go and hit the SSD disk. So frequently read data will be cached and stored in the SSD disk. So the end user will get good performance, or because the data is reading from the SSD disk. So if it's very rare data, if something the user is not at read before, so those type of reading, it will go unseek in the capacity disk. So obviously it will be a little bit slow, because it is reading from the capacity disk, which is magnetic disk. So that's a very major different in that. So frequently reading data will be cached in the SSD disk, and the non-frequently reading data will be stored in the HHD, magnetic disk. Okay, so that is a important thing. Another fact is, whenever user reading the data, if it will go and hit the SSD disk. If the data is not there, then automatically it will redirect to the capacity disk, which is magnetic disk. First time it will catch from there, it will read from there. Automatically next time the request comes in, automatically the cache will be stored in the SSD disk. So obviously you'll get a good performance out of it. And another thing is, when writing the data, what happen automatically when writing data, it will go and get the first. For example, as I said, we have ESXi host 1 and ESXi host 2. First of all, we have a data which we have a VM which is running in the ESXi host A. So the data will be spread across the ESXi host. For example, the data will be written in the host A as well as in host B. So in both location the data will be written. First it will written in the SSD disk. So it's called SSD flash disk write buffer. It's called write buffer. We have a percentage wise. For example, the basic is concept is 30 percentage. The first it will write the same thing in the SSD disk. Obviously, when we are returning some data in the SSD disk, it will be very much faster than the magnetic disk. So the vSAN will write the data in the SSD disk. Afterwards, after some time, automatically whatever rate data is written in the SSD disk, automatically it will write into the capacity disk later sometime. So it will not happen in a moment. I mean, when you're writing the data in SSD disk, it will take some time and it will slowly read, slowly write in the capacity disk. So that is what will happen inside the vSAN architecture. So this is the basic thing, and I will let you know the vSAN can only be enabled on the ESXi host cluster. So as I said, cluster is important. Another thing is the VM kernel port on each ESXi host is marked as a vSAN traffic. vSAN traffic must be enabled on the kernel port. And another thing is the VM object are stripped and mirrored across host. That is another important aspect. So for redundancy perspective, if any one of the ESXi host goes down, automatically we can easily we won't lose the data. That is very important thing. And read cache and write buffer are used to improve the performance. So this concept is very why we are using this, improve the performance. That's why we are using this thing. So this is a very important aspect. So this is the basic vSAN architecture overview. So hope everyone enjoy this video. It is very much useful for you. Thank you so much watching this video. Bye bye.